Good morning, everyone, and welcome to our technical session on technologies in water quality monitoring. In this session, there will be two presentations followed by a live question and answer section. My name is Antoinette Johnson. I'm the lab manager at the Cayman Islands Department of Environmental Health, and I will be moderating this session. First of all, I want to give a warm thank you to our conference sponsors. We really appreciate the support of Sandpit Contracting Cayman Limited, Deal Metering, Maya, Water Engineering and Pipeline Company Limited, WEPCO, Consolidated Water Company Limited, DART Enterprises Limited, Florida Aqua Store, Argo American. Thank you very much for your support. Before we get started in the session, I would like to briefly review a few items. You will have the opportunity to submit text questions at any time using the question and answer section on Whova. Questions will be answered during the live Q&A immediately after both presentations are finished. This is a collaborative session where all in attendance will be able to engage in the discussion during the Q&A. Now, I'm really pleased and honored to introduce our first speaker, Marcela Martinez Ebanks. Marcela has always had a fascination for data. She's the lab manager for Water Authority Cayman and holds a BA in chemistry from Union College, Lincoln, Nebraska, and an MS in leadership from Walden University. Additionally, she has a Class 4 wastewater analyst certificate. Marcella has spent the last 26 years with the authority's lab, doing what she describes to kindergarten students as coloring with chemistry. During Marcella's time with the authority, she is watched and as quality manager has been very instrumental in helping the lab obtain and maintain accreditation from the A2LA. Their certificate number is 19101 for anyone who wants to check. During her tenure, she has witnessed an almost tenfold increase in the number of lab samples. On a personal note, I have enjoyed a warm, collaborative, professional relationship with Marcella for just about all of those 26 years that she's been with the Water Authority. We freely share expertise, supplies, and very occasionally we gripe about job challenges, and that is the way we support each other, doing the job we both love. We'll now start Marcella's presentation.
Hey everyone. As previously mentioned, my name is Marcela Martinez, and together with Jerry Banks, we will be presenting for you a comparison of the methodologies that we've used here for the quantification of hydrogen sulfide emissions at the wastewater treatment facility located here in Grand Cayman. On the agenda for this morning, I will begin by giving you a brief introduction as to why we undertook this project, a summary of the two methodologies that we have used for the quantification of hydrogen sulfide, as well as the validation of these methods. I will give you an overview or a summary of the project phases, as well as the results, and a brief discussion. In 2017, the Water Authority received complaints about the hydrogen sulfide nuisance odors from the wastewater treatment plant. And as such, we undertook to begin a monitoring program to both quantify and identify the potential sources. The original wastewater treatment facility was commissioned in 1988 and consisted of 4 stabilization ponds with a treatment time of approximately 14 days. The headworks for this facility was located to the north of the stabilization ponds in this area. 2004, the authority added sequencing batch reactors, which is now the primary treatment system for wastewater. The basins for the SBRs are located to the southeast of what used to be the waste stabilization ponds, and the current treatment capacity is 9,500 cubic meters per day. The whole facility is actually located within an industrial area. Within the facility, we know that we have 2 sources of hydrogen sulfide emissions, the first being at a discharge pipe that serves as an overflow for the SBRs. And this one is located in the northwest stabilization pond. In addition to that, the headworks facility to the north of the SBR basins and to the south of the stabilization ponds is also a known source of hydrogen sulfide emissions. Additionally, we know that hydrogen sulfide is emitted from the wetlands both to the east and northeast of the treatment facility, as well as the solid waste facility, which is located to the west of the treatment facility. In undertaking the monitoring program, we looked at what the World Health Organization guideline values are for air quality in regards to hydrogen sulfide, particularly for preventing odor nuisance, which the WHO defines as somewhere less than 5 ppbs. Short-term average exposure is recommended at 100 ppbs and long-term exposure at just above 93 ppbs. Project data collection consisted of two different methods. One is a grab sample method and the other a composite sample method, or an average time period sample. The grab samples were collected using a Jerome J605, which is manufactured by Arizona Instruments. The procedure for the analysis using the J605 is an internally developed procedure, which we added to our scope in 2019. The composite samples, or the average time period samples, were collected using radialopassive samplers produced by Sigma Aldrich. The collection for using the passive samplers follows the NIR 6013 procedure for absorption and the methylene blue standard method for analysis. The J605, as previously mentioned, is a hydrogen sulfide analyzer for ambient air. The range of the instrument is 3 ppbs to 10 ppms for hydrogen sulfide. The instrument does, however, have some noted interferences, primarily ammonia, which can be removed through the use of a filter. Chlorine, which can also be removed through the use of a filter, although in the wastewater we do not add chlorine, so chlorine is not an anticipated interference. Also known to be as interference are nitrogen dioxide and most mercaptans, neither one of which we are capable of actually removing currently. The J605 instrument uses a functional test module, also produced by Arizona Instruments, to verify the instrument's functionality. The radialopassive samplers consist of an absorbent cartridge, which is coated with zinc acetate. The cartridge is then placed within polyethylene diffusive bodies for protection. The diffusive body can then be mounted on support plates, and these are then placed within shelters to protect the cartridge from weather elements. The absorption rate of the zinc acetate coated cartridges is temperature dependent. The passive samplers have been cited in a number of investigations for hydrogen sulfide emissions and air quality. Specifically, we found at least 2 studies that used them to measure hydrogen sulfide emissions from wastewater treatment facilities. The first one in 2017 by the US EPA Region 6, which used the radialopassive samplers for to investigate the emission sources of airborne hydrogen sulfide in the wastewater treatment system of the Georgia Pacific facility in Corset, Arkansas. In 2018, the radialopassive samplers were also cited as being used for the quantification of hydrogen sulfide emissions from the wastewater treatment plant in Curitiba, Brazil. The efficiency of the passive samplers has also been measured against a continuous measurement system similar to the J605, and it was found that for exposures below 14 days, both the passive samplers and the continuous measurement values were consistent for H2S. In both cases, the results were commonly expressed as concentrations averaged over specific time intervals. A crucial part of understanding the diffusion from the sources within the wastewater treatment plant is understanding the weather systems around us, both specifically the weather direction and the wind speed. As such, beginning in November 2020, the authority installed several Vantage Pro 2 weather stations. These are manufactured by Davis Instruments. The weather stations were installed at fixed locations throughout the wastewater treatment plant. The Vantage Pro records a number of parameters that are crucial to our study, including temperature, wind speed, and wind direction. The wind direction is recorded as secondary intercardinal direction points and then converted to azimuth degrees for data processing. The Vantage Pro instruments are located at the northwest corner of the facility, just slightly southwest of the discharge pipe next to the northwest stabilization pond. And another one is located at approximately 30 feet elevation on the northeast corner of the headworks. The validation of the instrument is done using the functional test modules produced by Arizona Instruments. The laboratory currently has two of these models. One is the low functional test module with a known concentration range of 30 ppbs hydrogen sulfide, and the functional test module is certified at 250 ppbs. The laboratory carried out comparisons of the J605 and the radialo passive samplers with known concentration gases. In the table below, I give you a summary of some of the radialo results using the FTM modules. On average, both the low-level FTM and the FTM, the radialos, read slightly higher than the certified value. For this project was done in several phases. In the first phase, during the initial phase of the project, between the periods of November 2017 and April 2021, measurements were collected at fixed locations. At each location, multiple readings were collected over a 2 to 5 minute period. The individual results were averaged, and the average reported as a result for that location at that date and time. During this period, a large percentage of the results, more than 71%, of the results were below the instrument's detection limit of 3 ppbs hydrogen sulfide. Sampling points focused primarily around the treatment facility stabilization ponds. 2 additional points termed dike and brachydaire were included as part of the wetlands monitoring. A distant sample to the southwest of the treatment facility was included in the early monitoring phase as a type of control or a reference point. The monitoring times occurred primarily during the mid-morning hours between 8 and 10 a.m. No data was collected between 8 p.m. or 4 a.m. This has been identified as a shortfall of the initial monitoring phase. A look at the data by range indicates that during the 5-year monitoring period, a decrease in the percentage of overall non-detects was observed. Additionally, an approximate 20% increase in the number of results greater than 100 ppbs hydrogen sulfide was also observed. A look at the data by site indicates at least 2 potential hotspots. The first one at point G, which is located next to the discharge pipe and the northwest stabilization pond. This site showed results of greater than 100 ppbs hydrogen sulfide approximately 22% of the time. The dike road sample located within the wetlands, specifically at the edge of the wetland ocean mixing point, showed results greater than 100 ppbs about 36% of the time it was sampled. Using the data gathered for the grab samples of the J605 data point and omitting any non-zero values, we were able to generate a heat map that indicated 2 sustained sources of H2S, or 2 hotspots for the hydrogen sulfide. The first being at the northwest stabilization pond, which is the pond where the discharge pipe occurs, and the second one at the northeast corner of the wetlands. The passive samplers were deployed over a 5-month period between December 2020 and April 2021. The samplers were deployed across various locations, with a large portion concentrated within the treatment facility itself. The reported values for the passive samplers represent the average H2S in ppbs over the exposed time period of the cartridge. The data consisted of 67 individual data points, and the exposures for the cartridges ranged between 45 minutes and 3 days. The sampling points for the passive samplers were located around the treatment facility, as well as the residential development west of the solid waste facility. Within the wetlands, we had several data points, or sampling points, one to the north of the facility, another to the northeast in the wetlands, another east-northeast of the facility, and one to the southeast of the treatment facility. The data gathered using the passive samplers confirmed the data that had been gathered using the grab samples, or the J605 sampling data points. For one, it showed that the highest concentrations were present at the southwest corner of the headworks. In addition to that, at Pond 11, or the northwest stabilization pond, particularly the southwest corner, showed a high readings of H2S. This point would be adjacent to the discharge pipe. Additionally, the pond 2-1 northwest corner showed the third highest reading. This would be approximately 30 feet downwind of the discharge pipe if the wind was coming from the northeast. One of the other trends observed was looking at the data based on the predominant wind locations indicated that, in general speaking, when the wind was from the northeast, the day-to-day average hydrogen sulfide concentration at each of these points was higher than when the wind was from the southeast. Looking at the same data in a bar graph form shows that the largest difference occurs at the southwest headwork sample point and the pond 2-1 northwest corner. Pond 2-1 would be the southwest stabilization pond. Map of the passive sampler results when the predominant wind during the exposure period is from the northeast produces almost identical results to those obtained from the J605. A hot spot is observed in the northeast section of the wetlands, and a point adjacent to the discharge pipe is also seen. However, a heat map of the passive sampler data points when the wind was predominantly from the southeast indicated a shift in the hotspots. There is still an observed hotspot in the northeast of the wetlands. However, the previously observed hotspot here adjacent to the discharge pipe seems to have dissipated a bit, and rather we see hotspots along the east property boundary and the northwest property boundary. This then led us into phase 2 of our project. Following the analysis of the data gathered during phase 1 of the project, which identified the discharge pipe on the northwest stabilization pond as a hotspot, phase 2 of the project was formulated in order to gather data on the dispersion patterns of the H2S emitted from the discharge pipe. Phase 2 of the monitoring would focus on the placement of passive samplers at incremental distances of 5, 10, 25, 50, and 100 meters from the discharge pipe, with additional sampling directly over the discharge pipe for both the passive sampler and the J605. One of the key assumptions that this phase made was that the wind patterns at this point was consistent with the island's documented predominantly northeasterly winds. The decision, however, was made to gather site-specific weather data before commencing the second phase of the monitoring project. Once weather data began to be collected next to discharge pipe, it became evident that the wind patterns next to discharge pipe were not predominantly northeasterly, whereas the wind patterns at the headworks and the northwest property boundary are predominantly easterly or southeasterly patterns. The wind direction at the discharge pipe is predominantly west-southwest. The difference in the recorded wind patterns at the discharge pipe has altered the plans for phase 2 of the project, which will now require a more complex dispersion modeling project. Based on the data gathered during this project, we have concluded that the data does indicate that H2S hotspots exist within the treatment facility at the northwest stabilization pond, immediately adjacent to the discharge pipe, and the SBR headworks. Data from the study has also indicated that H2S originates from natural sources, for example, the dikes and the wetlands. High levels of H2S at the northeast section of the wetlands were recorded regardless of the predominant wind direction. Analysis of the wind and H2S data at the treatment facility indicates the presence of hydrogen sulfide upwind of the treatment facility. We have also observed that the wind patterns around the treatment facility vary, and we've noted that the wetlands both north and east of the treatment facility have favorable conditions for the anaerobic production of hydrogen sulfide. Going forward, the next phases of this study will look at additional studies using the passive samplers with further comparison with the Jerome J605. We also need to look at addressing the interferences produced by the mercaptans for the J605 and look at different configurations to better identify the hydrogen sulfide sources within the treatment facility. Thank you for your time.
Thank you, Marcella, for your fascinating presentation. I would like to remind you to put any questions that you have into the Q&A section. And sorry, I'd like to remind you to put any questions that you have into the Q&A section, and we will answer them after Kodie's presentation. So I'm now going to introduce our second speaker, Kodie Scott. Kodie is a Senior Development Control Technologist at Water Authority Cayman. He has a strong passion for the environment and the ocean and has always been this has always been a staple in his life. His credentials include a bachelor's degree in environmental science with a minor in geographical information systems. He's obtained a master's degree in public health with a concentration on global environmental health. Kodie utilizes his educational background and experience in his daily work to ensure the Cayman Islands develops in a sustainable and environmentally conscious manner. His hobbies include football, tennis, and of course, as an island boy, everything water related. Kodie, it's now time for your presentation.
Hello, thank you. My name is Kodie Kelvin Scott, and I really appreciate the opportunity for the CWWA for accepting me to present at this conference. I will be presenting on the chemical composition of sargassum in the coastal waters in the Cayman Islands, and the main question is it safe for land use? With our agenda, we'll be looking at the introduction to sargassum, the sargassum testing, which included our materials and methodology, followed by our comparison of test results to the regulatory limits of those we chose from the worldwide standards. Then we'll look at our limitations, followed by our conclusions. Now let's get into the introduction. Sargassum, more commonly known in the Caribbean as seaweed, has always naturally existed. Sargassum is a genus of large brown seaweed that floats in island-like masses and never attaches to the seafloor. In 2011, scientists noticed that there was a major sargassum influx in the Caribbean. This influx caused major industries like tourism and fisheries to receive negative impacts. It just so happens that these industries are also the largest in creating revenue for these Caribbean islands. To date, there's limited scientific research on the land use application of sargassum, and this was a major catalyst of why I wanted to do this paper. The Cayman Islands may be small, however it is not exempt from the sargassum issue and must find ways to mitigate the concerns. Now let's take a quick summary of sargassum. In the top picture on your left depicts a map of Sargasso Sea. The Sargasso Sea was noticed first in the 1500s by Christopher Columbus's voyages, while he noted that there was large brown island-like masses known today as sargassum mats. Contrary to popular belief, sargassum is a free-floating microalgae that does not spend any of its life cycle on the ocean's floor. For centuries, the sargassum has existed in the Sargasso Sea, which is located around the Bermuda Triangle. A fun fact about the Sargasso Sea, it is the only sea in the world that does not have boundaries of land masses. It is bounded by ocean currents, such as the Atlantic and the Pacific. In the second picture, we show the two most common species of sargassum entering the Caribbean region. This is the broadleaf gulfweed and the narrowleaf gulfweed, are scientifically known as Sargassum natans and Sargassum fluitans. In the third picture, this is from NASA in July of 2011, using their new and improved spatial attraction model, also known as ISAM, in which satellite imagery showed the massive influx starting to enter the Caribbean region. As you can see, over the years, the darker red shows more dense sargassum entering the Caribbean region. Now that we have done a quick introduction to sargassum, let's look at the sargassum testing and the materials and methodology that we used in this research. With any major research, there's always a question of why. The purpose of this study was to validate the major concern in the Cayman Islands of why sargassum can be used as land application. There's major concern regarding this sargassum use on the groundwater and the soil. This is due to the Cayman Islands having a very limited amount of fresh water in its freshwater lenses. Preliminary testing of sargassum was done to determine whether the concern is valid or just a myth. The methodology adopted from the Water Authority of Cayman's accredited lab used chemical digestion to determine the chemical composition of sargassum. In this study, 6 sargassum samples were collected from the beaches of South Sound, Grand Cayman. Grand Cayman is also the largest of the 3 islands in the Cayman Islands. The Water Authority staff collected samples in April and June of 2021. The samples were collected from both the shore and in the water. Shore samples were termed dry, and samples collected while still in the water were termed wet. Portions of each sample were first washed with tap water and then with deionized water to remove particulate matter. The washed samples portions were dried at 102 plus or minus 2 degrees Celsius for 36 hours. Samples were then categorized in 2 groups for the 8 chemical parameters. The 2 groups were heavy metals and nutrients. The nutrients and heavy metals in which were tested in this study came down to those in which could be tested in-house by the Water Authority's accredited lab. These nutrients were ammonia, nitrates, and reactive phosphates, and the heavy metals were lead, iron, copper, arsenic, and cadmium. Spectrophotometric methods for ammonia, nitrates, reactive phosphates, total phosphates, iron, copper, and manganese were done. Those in red, the total phosphate and manganese, will be later discussed in part of our limitations. Anodic stripping voltammetry for lead and cadmium was used. For arsenic, samples were screened using the quick rapid arsenic test kits. This slide shows a table with all of our parameters and the methods that were used by our lab, also followed by the instruments that was used to carry out each of the methods. Anyone with a lab background would appreciate this slide with the info. In this slide, we have a few pictures of all 6 of our sargassum samples going through the same methods. In the first picture to the left, it shows an undigested dried sample being prepped for its testing. In the second, it shows the addition of hydrochloric acid and nitric acid. It is important to note that digestion was performed on a hot plate at 95 degrees Celsius using a 10 milliliter of solution of 4 parts of hydrochloric acid to 1 part of nitric acid. In this slide, we see some pictures of the second stages of the process. With the digestion of the hydrochloric and nitric acid, orange bubble reactions were seen, as you can see in the picture to the left. It is important to note for the analysis of nutrients and arsenic that 5 grams of the dried sample was mixed with 100 milliliters of deionized water. The sample mixture was then agitated on an orbital shaker for 45 minutes. The lead, cadmium, and copper and iron analysis was performed using 1 gram of the dried digestion sample. In the second picture, this is the digested sample fully reacted with before filtration. You can see, if you look closely, there is some white particulate matter left in the flask. This is some of the unreacted sample of sargassum. In this slide, we see 2 pictures right before the samples are being prepared for analysis. On the picture on the left, we see the digested filtered sample. Undigested insoluble matter, which was left from the previous slide, was filtered using the Fisher brand P8 filters. The picture to the right shows the final neutralized digested sample. The neutralization was done using sodium hydroxide. Now that we have finished with methodology, let's take a look at the test results and our findings, comparing them to regulatory limits of other nations' standards. In this slide, we have our 6 samples, both wet and dry, with their results for 8 testing parameters in milligram per kilogram. As we can see, some parameters, such as lead, were below the detection limit, while the most concerning is arsenic, in which we will look upon further. In this slide, we started to do some statistics and to create a summary of our results by each parameter. For these, we looked at the average, the maximum, and the minimum. It's very important to note that for arsenic, our average was 31.4 milligrams per kilogram. Our maximum for arsenic was 79.8, and our minimum was 4. For such stuff as lead and nitrates, all of our findings were very low, even some below our detection limit. For iron, our average was 96.7, with a maximum of 218.9 in one sample. Our phosphates, only the reactive, our average was 432.4 milligrams per kilogram, with a maximum obtained in one sample of 524.9. Once we had our final results, and after doing the statistical analysis with averages of mins and maxes, we wanted to compare our results to some of the developed countries' regulatory limits. It is important to note that during our research, we looked for many composting standards and land use application regulatory limits of composting. We were shocked that the European Union did not have set standards across its countries, but each country had its own limits. These countries shown on your screen included Austria, Belgium, Denmark, Finland, France, Germany, Italy, the Netherlands. These countries were selected because they had most of our parameters in their regulations. However, it was concerning to note that countries like Austria, Belgium, France, and Germany, along with the UK, did not have regulations regarding arsenic levels in their land use applications. We decided to add both UK regulation standards seen on your screen because one was for residential standards and one was for commercial and industrial purposes. However, as stated previously, they did not have arsenic standards. The EPA, however, had arsenic levels, which was 41 milligrams per kilogram, and was an important benchmark for our findings. Moving on further with the comparison of our results with the regulatory requirements of that of the US and the UK, we can see that starting off with copper, all 6 of our samples minus 1 fell beneath the 3 regulatory limits. Sample 1, however, did equal that of the UK's residential composting standard. For cadmium, all 6 of our samples, including number 4, which was not detected, were all beneath all 3 of the regulatory limits. The EPA's standard for this is 39 milligram per kilogram. Arsenic, which is the most concerning finding of this experiment, was 5 out of 6 of these was higher than the 41 milligram per kilogram set standard of the EPA. Like I said, this is the most concerning and highlighting finding of a result, and we will discuss this further in the next few slides. For iron, we decided to show this because of the 3 regulatory limits, none of them have standards, so these were our 6 findings. Now that we have gone through our findings and compared them to regulatory requirements of many nations in the world, it is very important that we move on to the limitations of our research study. As stated earlier in our presentation, the 2 parameters that were highlighted red were manganese and total phosphate, and these are 2 of our first limitations. Due to matrix interferences with method results, manganese and total phosphate results were not reported. This, however, shall be explored in future investigations with sargassum leachate solutions for both of these. An additional limitation was that our sample size was quite small, and we need more samples, both wet and dry state, for further analysis. This is very much recommended. Now that we have had a quick history of sargassum, we've gone through the materials and the methodology, we've compared our results with the regulatory limits, and we've looked at some of the limitations. Let's wrap it all together in a quick conclusion. The preliminary investigation highlights that arsenic is of major concern for land application in the Cayman Islands. This is due to the Cayman Islands having very limited amounts of fresh water and already having a high arsenic level in our soils. With initial findings of arsenic in sargassum exceeding the US EPA's sludge rule limit of 41 milligrams per kilogram, it should be considered whether the use of sargassum as compost in the Cayman Islands is safe. It is highly recommended to conduct additional testing of sargassum for the level of arsenic and that of other nutrients and heavy metals. To further conclude, it is important to note that currently across the world, there is no regulations for using sargassum as compost for land-based applications. This is of major concern. The sargassum issue for the Cayman Islands and other Caribbean countries across the region is here to stay and won't simply disappear. We cannot simply kick it out under the rug and hope it goes away. This is why I hope my preliminary investigation, along with my colleague Marcella Martinez Ebanks, can spur and act as a catalyst for fellow researchers to dive deeper into this issue to find a solution. Broader education and awareness is required for all stakeholders, as everyone has something at stake when it comes to sargassum. Tourism industries and fisheries are just the major flagpole sectors suffering, however more jobs and livelihoods are at stake. We must find a way to manage it in such a manner that public and environmental health are protected. In recent news, we are seeing innovative minds using sargassum as biogases and building block bricks. However, we must ensure that these are both safe for the environment and that of the public. This slide is of our literature used throughout this research. That concludes my presentation, and I would like to take this time to thank the CWWA for allowing me to present my research. Additionally, I would like to give a special thanks to my co-author, Marcela Martinez Ebanks, and her wonderful lab staff of the Water Authority's Cayman Accredited Lab for helping carry out this research. Now, I would like to take the time, if there are any questions, to answer them to the best of my ability. Thank you, and have a great week at this week's conference.
Well, thank you very much, Kodie, for your interesting presentation. And we apologize to the audience for our short break in transmission. And I also want to thank our technical team for getting us back up and running so quickly. So at this time, we're going to ask people to participate in the question and answer. Please keep your mic muted until you're called upon. If you have any questions, you can submit them in the Whova or in your Zoom, and we will try to answer as many as we can. Unfortunately, Marcella could not make it to today's session. However, her co-author, Jerry Banks, is here to answer any questions you may have. If we run out of time, you can find the speaker's contact information on the speaker's page on Whova. I have already received some questions, so I'm going to just scroll back to those so I can start. I think the first one we got was for Kodie. And that question is, were the test results for metals in sargassum in the same range as in other studies? I'm assuming in other studies in other jurisdictions is what they mean.
Yeah, thank you, Antoinette. That's a great question. With regarding other countries and with our literature research, I mean, most of the heavy metal results were very comparable to those, especially for arsenic. I remember keenly with there was a study in India and one in the Gulf of Mexico with where arsenic levels were very high compared to all of the other heavy metals. So yeah, I think that answers the question regarding they were comparable to other studies.
Thank you. It's I mean the source of the sargassum is coming into the Caribbean Sea, so that makes sense. Another one for you, Kodie, is if we cannot use sargassum as compost because of the high arsenic levels, what else can we do with it? And I that's a good question because I was also wondering whether there are any processes that we can do on the sargassum to reduce the contaminant levels so that we are able to use it.
Yeah, that's a brilliant question. And I think that's the main reason why I want this presentation and this paper to act as a catalyst for further research, because like I said, there's no current regulations regarding the use of sargassum, and it's quite a new dilemma. And I think we are seeing some innovation where people are using it as biogases. We've seen it being used as building block bricks in Mexico City, but we still don't know what the long-term effects of this process are. Like, are these bricks more susceptible to fires and stuff due to the heavy metals being in the sargassum's cell blocks?
Yeah, there's always lots of questions with research. Research identifies more questions you want to ask.
That's
The
correct.
next the next question is from Marcella, um, and I guess Jerry will address this. The wind direction at two locations was similar, but just the opposite direction at the third location. How is this possible?
So directly to the west, which would be the direction with the wind blows, there's a huge mulch trash moor if the map described that. And we think that due to that big hill, it's causing the wind to go sort of like this, but then come down the mountain, as we call it, due to like temperature differences and other aerodynamic considerations. That is why we have multiple weather stations spread out so we can get a full idea of the wind patterns.
Okay, so the geographical, be they land-made, contours are impacting the wind directions in that area. There's
Correct, that's what
another
we believe.
question. There's another question for you, Jerry. You said that the H2S program was initiated by Water Authority because of complaints of odor around the treatment works. Does the data support this concern?
What we're seeing is that there are high levels of H2S readings, but what we're trying to do is determine how far these gases are going, especially if they're leaving the property. And currently, it doesn't seem that they are traveling that far, and it does match background levels. So it is at this point, it's difficult to say if we are the main contributor because we have identified that all the surroundings are producing H2S.
Um, I had a question for you, and this would go to Jerry. Um, what are some of the challenges with ensuring the quality of data? Um, since this session is based on that premise and or on that topic, what are some of the challenges that you find with ensuring the quality of data? For instance, the calibration of your equipment, and you talked about checking your Jerome and so forth. Can you elaborate on that a little bit?
Definitely. So, as an accredited lab, we have to cross all of our T's and dot our I's. We do have to do a lot of maintenance on the instruments as recommended by the manufacturer. Some people can get away with not doing it, but we keep a very tight schedule, and that includes opening up the instruments, changing out filters, and also doing weekly checks. These weekly checks take a few hours, so it's very resource intensive. These instruments are also manufactured abroad, so what we also have to consider is that if there's a major failure within, we have to send it off, and there's not really much we can do on site. But yeah, it takes a lot to really ensure that the data is accurate. And in a nutshell, the way we do that is to use the functional test module, and these machines, they produce values of H2S that we know should be there. So if the instrument agrees with that, then that'll help us to be more confident in our data. I'd say another challenge is mercaptans, and we haven't fully quantified the extent that it is affecting the readings. But like I said, we are next to a landfill. That is downwind, so we don't really expect it to come onto the property. But in the event that the wind shifts, that may affect the data. The current filters that we're using is an ammonia filter, which will take out ammonia, and that is a very prominent gas on wastewater facilities. But currently, there's no way to take out the mercaptan. So I would say that is the major issue to get that positive interference out of the way. Yeah, that's what I can think of right now.
Okay. One of the things in the data, Jerry, that I noted is that there appears to be an increase from 2017 to now in terms of the number of samples you're getting over the 100 ppb range. Are you in a position to speculate on possible reasons for that, or are there ways in which your future research is going to look at identifying why we're increasing, getting increasing levels of H2S?
Not really in a position right now to say what would have caused that increase. If I could speculate, I could say improvement in methodologies of our sampling. There's also a lot of construction that has been happening over the past, I'm not sure, even years. It has it been that has affected the nearby environment, and that impacts the swamp significantly. And we have observed. It's hard to describe, but it's like a thick white scum, and that's usually associated with the anaerobic production of H2S, and that has been observed a lot around the construction sites as it's progressed. We can also look at our flow data, for example, of the wastewater plant to see if theirs has been a significant increase over these years and maybe correlate it back to that. But yeah, currently there's still a lot of data that we have to process, and we haven't gotten to that conclusion as yet.
Yes, and we've mentioned before that our usually our research leads us to answer a few questions and open up many more. So that's not unusual. I'm looking to see if we have any other questions, and I'm not seeing any more at this point.
Yeah, I see one from Corey.
Okay. Do you want to go ahead and answer that? Because I am not
sure.
seeing.
So he's asked, are the levels of H2S produced naturally and via the wastewater treatment plant considered hazardous to human health? And I would say yes at the certain hotspots. So both the discharge pipe and the offsite swamp spots hotspots have had readings over 10 times the World Health Organization short-term average recommendation of 100 ppb. However, an important thing to consider is that the extent of the dispersion, and the purpose of modeling dispersion for this project is to determine the extent of any potential hazard. So, for example, it may be hazardous to stay within a few meters of the discharge pipe for a period of time, or even like to spend a lot of time in the swamp fishing. However, the nearest residential site is 600 meters away. So, at this distance, the emitted gas from our plant has been diluted down to concentrations that closely match the background levels. And therefore, we don't really think that any health hazard is being posed to the general public at this time based on the data we've collected so far.
I see one more question for Kodie. Given the known levels of arsenic in Sargassum, are there any measures to remove it, or or isolate Sargassum to prevent environmental leaching?
I mean, that's a great question, and I don't think at this time we can answer it because we have to do, like I said, get more samples, get a better idea. What we know is that simply washing the sargassum or rinsing it in baths for as long as you want, it scientific research has shown that it doesn't reduce its salinity or the heavy metals due to the actual chemical composition being inside of the cell walls of the sargassum. So it must be digested or broken down over time, and that is of the major concern.
This question is coming from me. I mean, for all of us, the pandemic has disrupted a lot of our research and a lot of our data collection. Has it impacted um, your timeline for expanding this study?
That's for me or for Jerry?
Um, that one was for
or
Kodie,
both.
sorry.
Okay, no, that's fine. I mean, yeah, I think for both of us, or I think any researchers or in any field, I think the pandemic has caused limitations with time constraints just because we have, I mean, it's fair to say a more pressing issue, but I mean, it's still there and it's something that we cannot neglect, and it will be continued to be examined further.
Thank you. One last question came in for Kodie, and this is a big one, and it's kind of broad, so I'm going to throw it out there and I'll see what you have to say. Kodie, what is the Cayman Islands doing about the sargassum issue?
Okay. So as of, I think it was last year, right before the pandemic started, the Cayman Islands, various groups, DOE, hazard management, there was a sargassum task force that was enacted, and we started to look at the need for further research and awareness of the public. And like I said, we had started to get a good grasp and the right people were in the room. However, that's when the pandemic started. So it is there, but it needs more traction.
Yes, that's agreed. There was a lot of good work being done by that task force, looking at best practices and piggybacking on a lot of the research that's going on around the world. But we all got distracted with the more imminent threat to human health and public health. We just have a couple more minutes, and I just wanted to comment that I was very impressed with both presentations. Of course, I may be a little bit biased, but I believe that the laboratory is an integral part of any work that we do in the production, monitoring, and management of our water, our water, and our solid waste. So by conducting relevant research like this and ensuring that the quality of the data that is collected, um, our laboratories support informed decision making and in time adjustments and maintenance that keep our systems running efficiently. And I give you guys credit for all the good work that you do. Um, and we we hope that people enjoy the session. If you have additional questions for our speakers, this is to the audience now. If you have additional questions for our speakers, you may reach out to them by phone or email because their information is in the speakers channel on Whova. The session is now coming to end. I would want to encourage you to visit our virtual exhibitors booths to learn more about what they offer and how they can help you. And on behalf of the Caribbean Water and Wastewater Association, the Water Authority Cayman, and my own Department of Environmental Health, we're very glad you joined us. Thank you very much for attending.
Thank you.